So today we will be talking about parallel, series, and combined circuits. So actually these are dealing with resistance. What is a parallel circuits for parallel resistance? They have a common node. So for example, if we are dealing with two resistance here, this is R1 and this is R2. So there's a common node, so that means the two edges are attached together, and then let's call this A, and let's call this point here B. The electric current is, let's say it is passing from the left to right, so this is I sub naught, I'm going to put I0, and this is splitting up into, let's call this IU, passing through the resistance U, and I1 passing through the resistor 1. And then when the current is coming out of each resistor, they will be combined again together, and then you go back to your I sub naught, which is the initial current right here. So this is the case of parallel. So if the main formula is first, you need to calculate what you call the R equivalent, the equivalent of the system. So that would be 1 over R1 plus 1 over R2. Let's say, for example, if we say R1 is 17 ohms, R2 is, let's say, 10 ohms, and that gives you, if you do the calculation, R equivalent 6.3 ohms. So the calculation is based on this equation here, and just to do some practice, then you would know how to deal with this. Okay, the next step is, if we have something in series, an example of resistor in series is like this. This is the 17 ohms, for example, and this is combined with another resistance here. This is a 10 ohms. So if you want to know what is the equivalent for those two, so let's say we start off from the point A here, the node A, and the common node for both is B, and the end of the circuit is C. So if you want to have an R equivalent, it is very simple. In a series, the R equivalent is just the sum. You just add these two up. 17 ohms plus 10 ohms equals 27 ohms. So that's the R equivalent. This is R, the total resistor from point A to point C. Okay, so that's just to add them up. If you have 3, you add them up. If you have 4 or 5, you add them up. It's just addition. The last part here is what happens if you have, for example, a combined. So what you do is just treat each part and then combine everything together to get the R equivalent. For example, let's say we have R1 and R2 are in parallel, resistor 1 and resistor 2, and they are in parallel. Then we have here another resistor, let's call this R3. Now all of these is shunted or attached, if you will, to another one. Let's call this R4. You have an R5 here. So that's an example of combined circuits. So if we can calculate, for example, the equivalent, R equivalent from A down to B, and then that would be our R equivalent. So once you have this, then we can represent this complex structure with just a big R like this, and that would be our RAB. Now, so write a strategy path that will allow you to do your work in sequences. So let's say, for example, step number 1, we would be working with R1 and R2. So that will give you R1 parallel with R2. So you just use the formulas. Step number 2, I will call this R sub 1 parenthesis, because that's the question number 1. So question number 2, I will take R1 parenthesis, which is from question number 1, and then we just add R3 because those two are now in series. So let's say you get here R7S series. It's not 75 but 7S. Step number 3. Once you have those two, what you can do is just make a parallel between R4 and R5. This one here. So let's call that just R8. And then the last step, number 4, you take R8, because R8 is not all of these. All of these would be R8. And then you see that the R8 is in series with R5, so just add those two up. Then you get your R equivalent. Here is my suggestion. Do the calculations and find the R equivalent. So after calculation, I got this number here. Match it with yours. Now this time we're gonna give some numbers. So you're gonna end up with the R equivalent here. So let's say R1 is 1 ohm, R2 is 2 ohms, R3 is 3 ohms, R4 is 4 ohms, and R5 is 5 ohms. Do your calculation, then match it with the result I have here. So the answer I got here is 7 ohms. 7 ohms as your final answer for all of these. If you don't redo it, just go one step at a time. So you may have your own path. I just draw here. I do R1 and R2 parallel, R2, R3 series, the R2, R1, R3 equivalent parallel with R4, and then the equivalent of those big circuit, this big circuit, in series with R5. Then after calculation, you should find 7 ohms. So that's another path to reduce all of the circuit into a single R equivalent. Okay, just to do the practice.